Hi class, now we start chapter 3, which is probably the most important chapter, in my opinion, in the entire book, in this entire class. Since the uneven heating of the Earth's surface is what generates all of the weather around us, and that uneven heating is because of the energy we receive from the sun being received on the Earth, which is a spherical body. And so, based on latitude, the surface of the Earth is receiving a different amount of solar energy all across its surface, which leads to that differential heating, which leads to weather. Okay, so what we're going to do first is take a look at the Earth's revolution around the sun. It's kind of interesting, it's kind of counterintuitive. And so if we start off, we got the sun in the center of our solar system, and we'll represent the Earth over here. This distance between the Earth and the sun will vary throughout the year. The Earth's orbit or revolution around the sun is not circular, it is elliptical. And over time, it becomes more elliptical and less elliptical. Currently, we are less elliptical. We're almost as circular an orbit around the sun as the Earth will get. And so currently, on January 3rd, the Earth is actually as close to the sun as it's going to get throughout the course of the year. It's 147 million kilometers away from the sun on January 3rd, and we call that the perihelion. So the perihelion is when a body, the Earth, is as close to the sun in its orbit as it's going to get throughout the year. Okay, and so that's January 3rd. Interestingly, that it is in the middle of winter here. And so the revolution then, as we go around the sun on July 4th, sorry. Okay, so now we get to the point where the Earth is as far away from the sun as it's going to get throughout the course of the year, and this occurs on July 4th. So on July 4th, we call this the aphelion, and that's when the Earth is as far away from the sun as it's going to get throughout the course of the year, and that's 152 million kilometers away. Okay, and then throughout the next 6 months, it's going to continue its orbit around the sun. And so, one of the obvious questions then is, why are we cold in winter when we're actually closer to the sun on January 3rd? And a big part of that is, well, remember that we're talking northern hemisphere and southern hemisphere. So in the southern hemisphere, it's summertime for them. In the northern hemisphere, it's wintertime on January 3rd. So it makes perfect sense to the people who live in the southern hemisphere. To the people who live in the northern hemisphere, then it's a little counterintuitive. Here it is, the middle of January, the middle of winter. And we are as close to the sun as we're going to get, but it's really cold. And of course, the reason for that is the Earth is tilted 23.5 degrees on its axis. The northern hemisphere is tilted away from the sun's direct rays. 6 months later, July 4th, we're as far away from the sun. The Earth is as far away from the sun as it is throughout the course of the year. And yet it's the warmest time of year for the northern hemisphere. And again, that's because in this particular case, the northern hemisphere is tilted towards the sun's direct rays. And so we get a higher sun angle in northern hemisphere summer, which makes it warm even though we're farther away. And in winter, even though we are closer to the sun, the Earth is tilted further away, and so our sun rays that we're receiving are less direct and less intense, and so it's wintertime. So some counterintuitive ideas there, but if you think about it, it makes sense. And if you have any questions, make sure you let me know.